Hello guys. Welcome to today's stream. At least today, two viewers were on time, so thank you. We are going to give the others around like 9 minutes. Then we start. We start at 20:40 hours EAT. Yeah. So let's wait for the others to join. Welcome to the chat, my brother Nimfree. How dare you call yourself a noob, bro? Like, how are you a noob? And I learned from you. Like, you can't call yourself a noob, bro. You cannot call yourself a noob. I mean, we are all noobs. You're all noobs. You're going to learn together. Actually, today's stream is focused on, like, I'll make the whole focus. Like, if I was a beginner starting to do like an automatic speech recognition competition, how would I have approached it? Yeah. Hello, Rare Gem AI. Hello. Thanks for joining, man. I can see like new follower. I mean, not new viewers today. First, if you've not followed me, please follow me, man. Follow me. Shout out to my 5 viewers. This is the most you have had in the first 10 minutes. Yeah. So thanks for joining. Thanks for joining, man. If you're joining today, you're very lucky because this is the like first stream of like many other streams. Since you're starting a new competition today, today. Yeah. So shout out for joining, man. Make sure you hit that follow button, bro. Make sure you hit that follow button. Bro, I'm seeing my friends from Zindi here. Shout out to Abdul Rahman for following me, man. Shout out to Abdul Rahman for following me. Cool, 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 cool. Actually, today we are not. I don't think we are going to like do a training session though. Today will be a matter of creating baseline. It's going to be fun though. It's going to be fun. So yeah, just wait and see. It's going to be very, very fun. It's going to be very fun. Yeah. But if time allows, yes, we are going to do our first training today. Yeah, we're just waiting for like another 4 minutes or three, then we start. Then we start. Yeah, Jamie, you could not run the last live stream, bro. Why? Why? Tell me the issues you are facing. But if you want to, like, you must have like watched the second part, because the second part is where we are creating the data we used in the training. So if you have not watched the second part, you should. And I have linked the notebook in the second part, by the way. So you have to have run the data preparation notebook, then later go to the part 3 and do the modeling. Yeah. Loading data gave you issues. Did you run the second notebook? The second streams notebook? We are up to 14 followers, by the way. This is a massive win. The goal was to get to 25 followers by the end of the month. Uh, uh, oh, you downloaded the zip file to your drive? So we never. Okay, you have to run the second notebook before you run the third notebook, because you're not using the raw data from Zindi. We created images. Zindi did not provide us with images. They provided us with NumPy files. So if you want to run the that notebook, you have to like have run the second one. Yeah. So just go check out the second one. Yeah, it will help. It will help you solve your issues. Cool. I bet we can start now. We can start now. Welcome to the stream officially. Shout out to everyone who joined the previous streams. Just a recap. Yesterday we were just wrapping up. But if you like ran the like notebook I linked, yes, part 2, Reajam, part 2. You have to run part 2 to run part 3. So just a recap of what we did yesterday. Yeah. So we modified the image. I mean, we modified the model type. Nothing else. Everything remained the same. We also modified the augmentations. We reduced to like 3: resize, horizontal flip, and vertical flip. Yeah, and we were running it on the stream, but since it was taking a long time, we never even got to submit it. So here's the progress. It actually performed really, really, really good. So if you have not tried this model type, you should actually. The current score is based on this model. Actually, this notebook actually. Yeah. So if you have not trained this model, and it's pretty fast to train, you can train it in the T4 since it's a 224 model. Um, yeah, even the out of all predictions are pretty impressive. Remember, the maximum we had in the previous streams was 0.86. Right now, we improved it to 0.88, nearly 0.89, and it actually performs really, really good on the leaderboard. So let's check. Yeah. So here. Wait. Yeah, here it is. Baseline live stream. You can see the bait. You cannot see the whole name though. And it's called 0.8987, bro. 0.8987, bro. Like, just a single model, bro. Just a single model. And that will place you around top 20. Top 20, man. Just from a single model. You get top 20. And then the current score is based on an ensemble of just my cut boost and the bait bait transformer. So that's a trick I've given. That's a secret I've given you, man. So like, if you want to be top 10, currently we are top 6, bro. I told you we must win this competition. It's either we be number 1 or top 3. That's our goal. That's our goal. We must win it. So yeah, and I think this will be the last update. Though I'll give. So this was the recap. I've given you the secret to get to top 10 now. So go crazy, go crazy. Try that model I've showed you. Try the trick I said in the last stream while we ended the last stream. Although I've not tried it yet, but I'll try it and see if it improves the score. I hope it does. I'm not really sure, but yeah. The trick to getting to nearly top 5. Yeah, it's just an ensemble of cut and the new model. And now you can ensemble. Now, if you create more models, you can ensemble more models. That is what I'll be experimenting during the last 2 days. Yeah, and today that marks the end of this landslide detection. I'll now give more updates. So that's the last update. Yeah, and today we join a new competition. So like I said, this was a special stream because now if you join this stream with me, you see the whole process, the whole journey now. Because I know the first stream was impromptu. Not a lot of people not a lot of people like joined the first one. So I bet now this will be a good stream to start a new competition. You see, I've not even joined the competition yet. Yeah. So when you get to a new competition, if you have signed in, you get a join button. But in a class in a competition you've already joined, you get a submit button. Yeah, that's the difference. So yeah, so we join. You read the terms and and agreements. I have done this like a lot of times now. I don't need to do it on stream. So yeah, we accept and join, and it will turn to a submit button now. Yeah, while it's loading, I don't know why it's taking a long time. Maybe internet issues. Yeah, while it's loading, let's read the objective. So, voice and language technologies are transforming how people access essential digital services, from healthcare and government support to education and beyond. But for the more than 200 million Kiswahili speakers across Eastern Central Africa, this revolution is still out of reach. Uh, blah 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 blah. You can read that for yourself. In this challenge, your task is to build a Kiswahili, especially for my Kenyan brothers, man. This is we are creating solutions for the people, and Kenya, Tanzania, Uganda, DR Congo, and other Swahili-speaking countries. Yeah, so these are interesting challenge. So we are building a Kiswahili automatic speech recognition model that works under real-world conversational conditions without the cloud. Your solution should be lightweight, efficient, and optimized for real-time inference on edge devices. You may fine-tune an existing open source model or build one from scratch using any open data sets of your choice. So like for this, you have not been given any training set, by the way. So you can go to the internet, go crazy, find any data set you want, and fine tune your models. You've only been given a test set though. You've only been given a test set. As a bonus, you're invited to extend your pipeline by generating fluent English text replies using the PowerMin Alpha model. So they've given us, I think it's like a large language model, not large, a small language model. Yeah. So maybe you're going to dive into this in the streams. Yeah. But not today though. Yeah, so in essence, automatic speech recognition, in simple terms, you're given an audio and then you're told to like transcribe. For the people who know like transcription, where people were hired to transcribe like audio files, video files, now you don't need to hire human people. You train a model to do that for you. And yeah, so like the data, as I have told you, we have not been given any data. Yeah, so like we have only been given the test sets. And if you go to that link, so just go to this link right here. It's 7 hours of audio files. So you'll be given an audio file. Yeah, so you'll be given an audio file, and you can actually play it. So let me stop the audio for a minute, and now we listen to this audio files being given.
Upana baina ya mita 64 na 75.
Yeah.
Upana baina ya mita 64 na 75.
Yeah, so you have
mwanadamu. Biblia yasema hivi, Sabato ikifika kwa ajili ya mwanadamu, si mwanadamu.
Mke wangu ambadilika sana, tabia zimebadilika, yaweza kuwa hata mavazi yake yamebadilika.
Kuna wataalamu wengi wa sayansi, hivyo bado tunaamini kwamba suluhisho tutalipata.
Yeah, so in essence you're given these audio files and you're supposed to like train a model to transcribe what the audio is saying. Like in essence, when you're given an audio file, provide a text, like a sentence from that audio file of what that audio file is saying. That's what automatic speech recognition is. And yeah, and since I've not been given a training set, I'll show you where to get a training set. So we have like Mozilla has like a site called Mozilla Common Voice, which has like this information. Yeah. Just a minute. Yeah. So it has like you go to your browser, search Mozilla Common Voice, and yeah, go here, log in. I think I had an account before. I'm not really sure, but yeah. Nice. So like it's asked me to like do. I had an account. I'm not sure what happened. Swahili. Is that Swahili? Yeah. What? Bro. Yeah. No. What? Welcome, Cephas. You're locked in. Yeah. Wait, I've just saved this. Okay. So you can come and contribute to this dataset, by the way. So you come here, you contribute, be a good open source contributor, and contribute sentences, especially for Kenyans, since you don't speak fluent Swahili like Kiswahili Sanifu as our brothers from Tanzania. You can come here and contribute. But what you are interested is like in here listening or here download. Yeah, and there are there are very many like open source data sets, but what you're interested in is Swahili. Swahili. Yeah, and you can see like a lot of data for Swahili. So here is where you get the training data. The training data, since Zindi has not provided us with the training data, so you have to like find that for yourself. I've linked the link on the comments. Yeah, so you have a lot of data. You have a lot of data, especially these for 2025. These are new ones. So yeah, these are new ones. These were there last year. A lot of data, a lot of data. So you can come find here, and also on HuggingFace. On HuggingFace, they have this data on HuggingFace. So you don't even need to like come to their official like website to find the data. So yeah, so come here, search MCV Mozilla. Yeah. Data set. Yeah. Here you go. So Mozilla on Hugging Face, and they have like various versions. So this is version 17, version 16, version 16, 0.0, version 16.1, version 15, version 14, version 12. So you have a lot of like data to train on, man. So yeah, honestly, you have to agree and access the repository. Then you can filter for Swahili. I think there was somewhere we used to filter for Swahili because like the whole dataset is pretty large, so you have to filter for the language you want to use. Yeah. Where is it? I think it's yeah. There was somewhere we used to like filter for Swahili dataset. Cool. So part one has finished. I've shown you where to get the dataset, how to access the dataset. So now we go like in depth what automatic speech recognition is. I've just given you a vague explanation, but in essence, that's the main point. That's the main point. Right now, I see I have like 6 viewers. Shout out to my viewers, man. If you have not followed me, please follow the boy. Yeah, make sure you follow me. Actually, follow me right now so that you can continue. And I've also said, like, in this stream, I'll assume that everyone here has never interacted, including me, has never interacted with any automatic speech recognition like problem. So what would I have done if it was my first time participating in an ASR competition? So like, yeah, I'm going to show you everything that I would have done. But right now I've trained like, okay, I'll show you that later. I will show you that later. Cool. So the first thing I will do is go back to Zindi, and then search for competitions, previous competitions that are ASR related. So for example, if you just search Mozilla, I'm pretty sure you'll get a lot of competition, especially these two actually 3. Yeah, this competition ran in the past year, and I'm not sure if Julius is here, but he won the Nairobi chapter. Julius, yeah, you can see like Julius won the Nairobi chapter. Shout out to Julius. And then my friend Ronnie and his team. Ronnie and his team won the 2nd place, and then I was 3rd place. So this is the first thing I would have done. So first, research for previous Mozilla competition, because when you research for previous Mozilla competition, I'm pretty sure if they never shared their solution, it means maybe people like already shared their solution. So you have to like now start researching who are the winners, what is their GitHub, go to their GitHub, search for repositories that have like these placeholders or something. Yeah, and then you'll get the Wayne, follow the boy, man. Follow the boy. Actually, Wayne was part of this competition last year. I'm pretty sure, yeah? Yeah. Wayne was part of this, Los Alamos. It's actually the same. It's the same competition, but now with new data. So I'm pretty sure you'll have a head start. But yeah, we will all have a head start because we are discussing this on stream. So yeah. So for example, Julius. Do you know Julius GitHub? Or you don't know? I mean, if you're a Zindi competitor and you don't know your fellow competitors' GitHub accounts, you're joking, man. You're joking. Then you're not a serious competitor. I'm not sure if it changed. Yeah. Here he is, bro. So I go to his GitHub. Now this is the steps I take, bro. Like, trust me, this is the same steps I take. And you have it on his GitHub. You have it, bro. Like, so for example, this was it. I don't know. Okay, this was the application part. I don't know if he he published, but I'm pretty sure he did. Did he? Okay, he only published the second part of the hackathon, where we're supposed to build applications from the models we trained. So yeah, this is also an interesting repo. You can go check it out. Then, for example, I see, oh, Julius never posted his solution. I go to the second placed people. For example, Ronnie. Ronnie is a good friend of mine, actually. Ronnie Leon. So you come here, search for him on GitHub. Ronnie Leon. Yeah. And then let's see if he posted his. I'm pretty sure he did. If he never did, bro, my bad guys. But you're not at a loss, bro. You're not at a loss. Sorry guys, he also never posted his solution. Yeah, and then I come to the third person. Who was the third person? Kolesh JR. You go search him on GitHub. Who is this guy, bro? Who is this guy? Let's search him on GitHub. I also don't know him, man. Yeah, and search for Mozilla. Bro, he posted his solution. Thank you. So this is where I go find. This is where I go find my first baseline to use. My first baseline to use for the training phase. Yeah, so you can see I posted both my approaches, bro, like both of them. So I trained a Web2Vec. This is a model from Facebook. Okay, when you find something like this, just download the notebook, and then when you download, I had already downloaded it, so like I'll just show you. Go to your Colab and upload it. So I had already downloaded it, so yeah. So this is actually the steps I take, bro. Like if there is a previous competition, the same like objective, I just go check previous competition, go stalk the top competitors, go stalk their GitHub, find if they posted their winning solutions, and then use it as like a baseline. So yeah, so this was my notebook for training. I think this was training alone. Yeah, so we train, and we pushed the models on HuggingFace. So go check this repo in my GitHub. Yeah, I'll link my GitHub actually right now. And actually, if you go just to the dashboard, you'll see like multiple ASR projects here. So go check the ASR projects. Most of this Mozilla Swahili transcription, because it's actually the same project, but only the test data has changed. So yeah, you follow the same exact steps and improve it. Don't like copy paste blindly though. Yeah. So I'll link to my GitHub here. Nice. So after I go on GitHub and find the like if a solution has been posted, the next thing I do, for example, this is only ASR related, automatic speech recognition, because I know for ASR projects, people upload their fine-tuned models already on HuggingFace. So the next thing, you go to HuggingFace and search for Swahili models. So you search for Swahili models. Swahili. Yeah. So yeah. And then come here and filter for automatic speech text to speech to text. Do they have speech? Yeah, I think they do. Speech to text, text to speech. Yeah, automatic speech recognition. Can you see? Yeah, you go search here, automatic speech. How fast was Web2Vec training? Bro, I really can't remember, man. I really can't remember at this point. But yeah, I really can't remember, to be honest. Let me see. Let me see if I logged the training time. Train runtime, 10,992 seconds. 3 hours, nearly 3 hours. Yeah, and NVIDIA Nemo, I think that was the one which was taking a lot of time, if I'm not wrong. But honestly, I can't remember. I can't remember. Yeah, but you'll see. This doesn't even have logs. Yeah. We will train, and then I'll be updating on the stream how long it took. Yeah. So we come here. Bro, these are tricks I'm giving you, bro. You can't even win this competition without. Okay, you cannot win without doing the training, but you can create a very strong baseline without any training, by the way. So you come here. You see, so like this is for Swahili, ASR Web2Vec the voice. What what error rate did they have? 23.16. Okay. So you log that. You log that. Then you come. So here is College JR. He was number 3. This was Whisper. Okay. He said in the stream he never used Whisper, so you ignore that. Yeah. So there are many Swahili models here, very many actually, and yeah. Myself, I had a lot of Swahili models. Yeah. Let's see. Let's search for Web2Vec. Yeah, so we have, okay, most of them are private, but honestly, I don't care them being public anymore. So you can go, this can be your starting point actually. I'll just make them all public. But the thing is, I don't remember which was the best perform, which was the best performing. So you have to like try all of them, man. You have to try all of them. Yeah, I think all of them are public now. Yeah, except this. I'll also make this public. Nice. So we have our Web2Vec models. We have our Web2Vec. So that person published his models on HuggingFace. Okay, let me go test it as to be my baseline. So a baseline is the score you work hard to beat during the competition time. Yeah, but even the second place people publish their models. You can come here, search for Ronnie. I don't know it. Adeb Schneider, yeah. You can come here, search for Ronnie. His is like public also, like you can see. So you have this Ronnie model here. Eval lost, eval where it was 0.1481, bro. 0.1481. This is actually so good. Yeah, you can come now after you've after you've stalked the winners and found their models on HuggingFace. What do? Okay, maybe some of them, I'm not sure, but some of them, when they realize there's a similar competition, they make their solutions private, meaning that they have that advantage. But since everyone here has like the second place and the third people have open sourced their solutions, so you can use them as your first baseline. So okay, now I have seen like Ronnie trained our Web2Vec, so let's copy it and then yeah, go to a new notebook, for example. But even before like testing even that model, you have to understand what automatic speech recognition is. And HuggingFace has very good resources actually. So if you search HuggingFace automatic speech recognition, they have very nice articles and notebooks as well, which are well documented. And yeah, we're not interested in that. We're interested in the you're interested in the like blog. We're interested in the blog. Wait, they did have a blog. I'm not. Yeah, so here they explain automatic speech recognition converts a speech signal to text, mapping a sequence of audio inputs to text outputs. Virtual assistants like Siri, Alexa use ASR models to help users every day, and there are many other useful user-facing applications like YouTube captioning. I'm sure everyone here has watched a YouTube video where the caption is presented while the video is playing. Or if you're an anime fan and you're not a dub, and you're not a dub fan, yeah, you're not a dub fan. They say like us people who love the like the dubbed ones are not real anime fans, but me, I love the dubbed ones. But if you're an anime fan who loves the non-dubbed ones, the ones which are speaking Japanese, they have like a subtitle. The subtitle is like the okay, that's translation though. So the video is transcribed to Japanese and then Japanese is translated back to English. Yeah, and they have a guide. So here fine-tune Web2Vec. So they're very okay. The ones I know, Web2Vec, Whisper, and CTC. That's from NVIDIA. But today we're going to focus on Web2Vec first. Then the other streams are going to see like the other models. So here they have given you a guide to fine tune a web to vec model. You can go read it. Yeah, and they have a notebook as well. So I come to this notebook and then I start reading, man. Are you okay with the? Are you guys okay with the black? Oh, I hope you can see though. I hope you can see. Cool. So I cannot do a better explanation than this blog post. This was my first. Okay, it's not even a blog. It's a notebook. This was my first notebook I used like while doing that previous competition. So it explains what Web2Vec is, retrain model for ASR. It explains the pre-training objective. That's a nice visualization there. Yeah, so like you can go through this notebook. I'll link it as well on the charts. Yeah. So after you've read this notebook and you've understood what ASR is, like in depth, you already know ASR what it is, but if you want to like know the technical bits and to run your first training objective, you can go read about this. You can go through this notebook and understand and like try to understand what they're trying to explain. We're going to go through this notebook later, but right now I want to show you what I would have done. The first thing I would have done, I wouldn't even go to training first. I've seen that there are models on HuggingFace and they've already been fine-tuned on Swahili. Why am I even going to train a model when I've not even tested those baselines yet? You have like to test the baselines and then you try to beat those baselines. Yeah. So we're going to rename this to live stream ASR. Yeah, live stream ASR. And now, since we have AI, we're going to use a lot of AI today. So this I'm assuming a beginner who wants like has never interacted with any ASR models before or any ASR training notebooks before. Yeah. So the first thing is to link your. Okay, we don't even have the training set on our Google Drive, but it's on HuggingFace though. It's on HuggingFace. And actually for this notebook, this is an inference only. We are trying to check how the models which are present on HuggingFace already fine-tuned on Swahili, how they perform. Yeah. So you don't even need Google. I mean, you don't need to link the data in your Google Drive because it's already on HuggingFace. So from HuggingFace, I'll show you how to use AI. Yeah. So import everything I need to use. Can you see my? I don't think you can. Okay, this is an overlay. Sorry guys. I don't. Can it be seen on the live stream? Sorry guys. My bad. But if you click this generate right here, you see this generates. Yeah, you see this generates. Yeah, it's an overlay, so it cannot be seen on the live stream though. But if you click generate, it will give you a cell for you to type anything you want to ask Gemini. So it uses Gemini model. So I'm going to use it in the whole of this live stream. Import everything. So like, okay, I'll say what I'm prompting. Import everything I need to perform inference on a fine-tuned Web2Vec model. Yeah. Oh, you can see now on the live stream. Yeah, you can see. So you have from transformers, import auto model for audio classification, Web2Vec, touch. I don't need this though. I need the pipeline one. Yeah, the HuggingFace pipeline one. Okay. Oh, so I have to link my GPU, bro. Let's use L4 today. Let's see. But we also need data sets, man. We also need data sets. Why has it not imported data sets for me? Like from HuggingFace? No. From data sets, imports, load data set. Do I need dataset dict? I don't think I need dataset dict. Accept. Cool. Now, and then we go back to our test. So remember, they've given us the test data only. So come here to data, find the test sets, copy this link right here. Yeah, copy this, bro. They've also given us the code here. So process audio files, your model to predict. Yeah, we can copy all this code right here, and then paste it. We don't need these. Okay, we need it. Do you need pandas though? Maybe later. Yeah. So audio. Nice. And then you have your data. So they have given you, but this is pretty slow. Yeah. So let's see. If it's a large data set, it will take. Oh, and you have to link your HuggingFace token. Plus, you need to accept the terms when you go click on that just data sets. You have to accept the terms. Yeah. Request secrets. Yeah. So how to add secrets? You see this key right here. This key right here. So you can see all my secrets here. So like for example, Gemini, HF token, Llama Path, OpenAI, 1DB, and this it's for like Azure Document Intelligence. But the one which we are going to use is the HF token. So go to your HuggingFace account, go to your HuggingFace, go to settings, access tokens, and create your access tokens. And then you come and add it on the secrets like I've shown you. Yeah, you can just add it. So to add is pretty simple. You say HF token, and then you copy paste whatever you have here, and then yeah, you close these parts. But right now I don't need this, I already have it. Nice. So our data has loaded. So you can see number of rows 4089. And then we now use our Gemini. Given this data set, can you guys see actually? Okay, it's an overlay, sorry guys, but you'll see it when it appears. Nice. So like the prompts given this dataset, can you generate code to perform inference of the audio, to generate text from a fine-tuned web-to-vec model, and then save the results in a submission file? Yeah. In the age of AI, bro, you don't need to struggle, man. You don't need to struggle. Okay. Yeah. Auto run. Can you guys see? Yeah, so an agent is doing the work for us, man. It's preparing, it's loading the fine-tuned model and processor, creates an inference function, apply the inference function to the datasets, format and save the results. I hope it works on the first try. I really hope it works on the first try. Yeah, so it's creating a task, loads the web2vec processor, auto model for for classification. Okay, this is totally wrong. I need to change all of these. Yeah. Client error, unauthorized. Yeah, I need to change that. Yeah, yeah, yeah. This works. Create an inference function. Okay. Honestly, the AI is doing, but there are errors. So these errors you have to like solve them yourself. But honestly, this is too much work. This is too much work. There's a simple, there's a simple way. I really don't need to do all of this, bro. I really don't need to do all of this. So I'm going to cancel this and use my experience. The AI is doing a lot of nonsense. Okay, it's not nonsense. It's doing a lot of things, but yeah, I'm going to delete all of these. Yeah, but it has tried. It has tried though. It has tried. It has tried. It's not nonsense. Yeah. So you have the data. What we are interested in is like the pipeline. Yeah. So we call pipe is equal to pipeline. It's actually a one-liner, and then specify the task, automatic speech recognition. It's a one-liner, but the AI was doing a lot, man. Like using the raw torch. That is a simple way, but either way, what you prefer, But we don't need. We want to use the fine-tuned one. So where was it? Where was that model? Where was that model? We search for our friend. I'm pretty sure it's going to be mad, but yeah. Or maybe we use mine. Let's respect his privacy. Let's respect his privacy, bro. He has not given us consent, but it's public though. You can use it, man. You can use it, bros. You can use it. So, but let's use mine. Yeah. But I can't remember which was the third place solution though. Nice. So we have our pipe, and now let's see. If it loads successfully, we are very lucky. We are very lucky, man. Nice. It's loading. Yep. Let's wait for it. Now, since we have the pipe now, we can guide the AI appropriately. I hope it works now. I hope it doesn't do a lot. Yeah. So automatic. You specify the task you're trying to do. So what is pipeline? Maybe that's a question you wanna ask. If you go everything, always go back to the documentation. Yeah. So pipelines are a great and easy way to use models for inference. These pipelines are objects that abstract most of the complex code from the library, offering a simple API dedicated to several tasks, including named entity recognition, sentiment analysis, feature extraction. You don't need all these tasks, but the task you're focusing on is automatic speech recognition. And then you specify the model, the fine-tuned model. You can specify the base model or a fine-tuned version of it. So here we are specifying the fine-tuned version of it. Here device is the GPU. So in essence, like if you have multiple GPUs, yeah. Yeah, let's allow the AI to do it. I hope it does not like, bro. bro, I have already loaded the pipe, man. What are you doing again, man? Please AI, bro. Please AI, man. TQDM is not important. Okay. Sample audio, ID sample predicted. Nah. Quit, bro. Quit. Stop. Stop, bro. I know. It's actually trying that. I had not yeah. For sample into KDM, DS, audio data, pipe audio data. You can also print the transcription and see.
Woke up this morning. I made some coffee. That was nice.
Yeah. I hope this works now. When passing a dictionary to automatic speech recognition pipeline, the dict needs to contain a row key containing the NumPy array or touch tensor representing audio and a sampling rate containing the sampling rate associated with that array. Okay. Let's go back to our AI, man. Hi.
Wonderful day.
Thank you, AI. It looks like pipeline expects the audio data in a specific format, a dictionary containing the raw audio array under the key row and the sampling rate under the key sampling rates. Extract this and pass them to the pipeline correctly. But if the sampling rate has not been provided, which are the default sampling rate to use, man? I bet 16,000. Accept. Yeah. The sampling rate has not been provided. I think it's 16,000, if I'm not wrong. But we can ask. What? Yeah, 16,000. So 16,000. So we remove this row. Cancel. Sampling rates 16,000. Raw audio data bytes, transcription. We expect a numpy ND array or touch tensor as inputs. Got class bytes. Come on AI, bro. Do something for us, man. Do something for us. What? What is it doing, brother? There's no array. It's only audio. We need to decode the audio bytes into a suitable format before passing it to the pipeline. Come on, I know this will return an error still. Yeah. Decoded audio. Sampling rates. Decode the audio bytes and get the sampling rates. Bro. Decode the audio bytes. Audio feature to decode example, transcription, sampling rates. Bro, we're going to be stuck here. Please install touch codec. Okay, we are going to install it. Bro, it's already installed, man. It's already installed, bro. Come on, man. Okay. People on the chat, can you help me? Help me debug this issue, bro. Help me debug this issue. I really am not sure how to solve this issue though. Let's see. So you have audio. It's in bytes. There's no path. Okay. And here the sampling rate, this should be 16,000. ds.features audio. Okay. For sample into QDM audio data is equals to sample audio. Decoded audio. Row decoded audio sampling rates. In transcription. Bro, now I have to install all of libtorch. What? Like, maybe we We should have used the raw touch version that the AI had presented us, man. Because what is this? Like I have to install FF, bro. And to install these things on Colab, it's pretty tough. Um, yeah, yeah. This already, honestly. Okay, man. People in the Twitch chat, please help me. Help me solve this issue, bro. Help me solve this issue. My 2 viewers, please come on. Type in the chat. But anyways, we're going to use AI to do this, bro. We're going to use AI. So I'm going to like go to Google AI Studio. And then, yeah, we have to get this working today, bro. AI to the rescue. I hope it works this time. Please, AI, man. Please, you're coming to replace us, bro. Come on. Do a great job. Okay. Processor, error loading, okay. And you have your bytes, file name, okay. Record, okay. Transcribe audio, item, audio bytes, okay. Inputs, sampling rates, okay. Input values, okay. Yeah, this looks this looks good. So like I'm going to copy it and try it right here. So we're going to remove some things though. Let's quit that. We're going to remove some things. Device coder, okay. Okay, we already have the data sets. This is the inference function. PS, okay. Oh, sorry. I have to. We have to specify the fine-tuned model. But I don't. Okay. Let's see. Processor. Okay. Let's. Is it loading the model? I'm not sure. I hope it is. And then yeah, so it loaded the model successfully. Now it's dataset preprocessing. The S is not defined, bro. Are you kidding me, bro? No problem, brother. No problem. Yeah, no problem. Okay, it seems like it's working. Break. Yeah. It's working. So we cannot delete all these, but all these. That remains. Looks like pipe. Okay, we are going to revisit that some other day. I don't have the energy to go in depth to solve that bug, but yeah, we're going to come back to that later. Transcribe audio. Okay. Cool. I honestly hope it works now. Yeah. The struggles you go through. Result dataset. Okay. Results dataset. Audio. Seems like it works. Yeah, it's working. It's actually working. So like this is the file. We can actually play it. Um, we can play it. We can play it. Let's play it. Okay. Speech sampling rates. Ah, bro. Okay. I'll come back to that later. But it seems it's working because like it's printing the transcriptions. So we just need to save these submissions to wait, how does like the submission file should look like? Or it should have a file name and a text. So results. Yeah. Yeah. So we will let it run for. Yeah, we'll let it run. Remove the printing. Nice. So pd.data frame. Yeah. Even before we save it. Okay, looks good. Looks good. Looks good. Dot shape. Okay, looks good. Baseline, submission, print. Instead of doing all these though, let's see some of the transcriptions. We need to like fix the playing issue, and then yeah, this looks like at least good Swahili. It looks like a good Swahili, but we never know. We never know. We never know. Let's see. Let's see. Let's see. We never know. Wait, I'd already joined, no? Let's see. Bro, missing entries for IDs. Okay. Okay. Baseline, file name. Yeah. Okay. Okay. So like some of them return like empty transcriptions. So for that, sub dot is now that's some. So I'm going to do transcription. Transcription is equal to np.where sub transcription is equals to like an empty string, for example that, and then replace it with like what will you replace it with? Where sub is equals to, you're going to replace it with a space maybe, and then for the rest retain the transcriptions. Bro, NumPy was important that I would have cast a lot of very many times in this stream, but I was told by my dad to not cast, so like I won't cast. But I would have cast like a lot, bro. A lot. Yeah. That's 694. Oh, okay. Transcription. That's a 694. Come on. Yeah. So I bet. So right now it's a space. Before it was like an empty string. Hopefully that fixes it. I'm not sure if it's going to fix it. If it's not going to fix it, you're going to like just fill it with a random character. Maybe just one character. Yeah. Wait. It should be like it should be like a new baseline. Okay. It should be like a new baseline. It's still downloading. Yeah, it should be like baseline submission 1. Yeah. Yeah, sure. Thanks for joining, man. Thanks for joining. Today there's been a lot of bugs, but we are nearly there. We are nearly there to make our first sub. Hopefully it works, man. Like, hopefully it works. Nice. So we got our first sub, 0.60. Yeah, we got our first sub. So we are currently at position 5. We are currently at position 5. Yeah. So now that we have a working pipeline, the experiments now will be much faster. So what we are going to do is, instead of saving as baseline solution only, we need to like add a config, and then we save it to with the image. I mean, the model name. Yeah. Dot replace. Replace the backslash with an underscore. And then we don't have the config yet, but you're going to create it. So create a config, dataset path is equals to that, and then model name, yeah, device, yeah, dataset path. Remember, we have not changed anything. This we went just to HuggingFace to like stock for models that are already fine-tuned on Swahili, and then we are using them. So dataset path, ds, okay, model name, g dot model name. So with that changed, all our submissions will be named with our model. Device, the device. Yeah, I think that's it. That's it. I think that's it. Yeah. So we can delete this now. We can delete this. We can delete all of this, and then yeah. Now we go back to our HuggingFace. We go back to HuggingFace and now stock for models, for more models. Swahili. Oh no! You can try mine. Like, I think we have multiple submissions, so we can try all my models. I'm not really sure which one the previous time. Yeah, I'm not really sure which one the previous time, but yeah, I'm not sure which one the previous time, so I'm just going to like pick randomly. So we have tested, which one have we tested? 1412. We can test the 1390, October 16th. Yeah, we can test this one. Yeah. And hopefully it performs much better. If it can't, we are going to stock for more. There's a Kenyan company which has been working on Swahili transcription for a while. It's called Zinc. Yeah, it's called Zinc, I bet. Yeah. No. It's called Think Kenya. Yes. So I think Kenya is a company that has been working on Swahili transcriptions for a while. They have this Web to Vec model, which is a good model, I think so. So we are also going to test this Think model. Bro, like it was this simple. Are you kidding me? And the way we struggled, bro. Like, what? Are you kidding me? Okay, we are going to try this next. We have really struggled in this. Processor is not defined. What? Oh, okay. Imagine the pipe version was like as simple as this. Bro. Bro. No way. No way. No way, man. No way. No way. Yeah, we are going to try the think model next. Oh, okay. Maybe. I mean, the part is correct. What are you kidding me? Oh, yeah. Expected string or okay. We are going to try. I don't know why that's failing. Let's try this pipeline. Let's try. Let's see if this pipeline works now. We have to load the data first. Okay, we have the. If this works, bro, like, bro, bro, if this works and the way we struggled the other time, even the AI never got it right. God. Let's see. If this works, oh my goodness. Yeah, so honestly, yeah, go to the HuggingFace, go to HuggingFace, find a model fine-tuned on Swahili. Yeah, and now just create strong baselines. For example, now if you train your model, you have to beat my baseline. Yeah. Um, yeah. And there are many. You can go, yeah, filter for web to Verc ones and try them all. And I can even see my friend's model, Leon's. Yeah, you can try them. You can try them. You can try them. You can try them, literally. Yeah, this never worked the previous time. So yeah, the pipe one. Okay, let's not delete it. Maybe if someone has a GPU and has FFmpeg downloaded, yeah, this might help. So I'll just leave it here. Yeah, if someone finds a fix, please share it on the discussion. Yeah, but we're still going to use the Think model. We are still going to use the Think model. And let's see if it will perform well. Okay, that works. I don't know why the other one was like leading to like restart issues. And now let's see if the Think model will perform much better than my models. Yeah, we're going to try this one model and then we end the stream. So I'll leave the rest for you. Yeah. So the goal of today was just creating strong baselines to beat. We currently have a 0.60. Let's see if we'll find a new contender. Yeah. Who are still on the stream? I can see 2 viewers. Yeah, my bad. Today has been uh there have been a lot of bugs, but don't worry. That's how it usually is, bro. That's how it is. Yeah. But remember, this is a large model, so but it can run. Yeah. The only limitation, the only rule that we have, is that it should run on a T4. No, wait. I had seen a rule that it should run only on a T4, but this can run efficiently on a T4. So, if that's the only rule, bro, I think yeah. To reflect the realities of deploying AI, it should run on a single T4 GPU with less than 16 GB RAM. Oh, we're using L4 GPUs, bro. Wait, is it? Can this run on a? Yeah, it can. It can run on. It only requires like 6.9 GPU VRAM. So yeah, I think we're within the limits. Yeah. Nice. I think it has finished. Bro, this looks so good, bro. Like bro, this is perfect Swahili. Like if there, this is perfect Swahili, bro. Like perfect Swahili. Bro, this looks so good. Upana baina ya mita 60 na bro, this is so good, man. Like honestly, this will be a better baseline. I think this will be a better baseline. The Swahili was perfect. What? And the Swahili was perfect. And the way the Swahili one was perfect, man. Yeah. I'm sorry, guys, man. Yeah. So the goal will be to beat these two scores. I wonder what Abdurrahman is using. Yeah. Should we try another one? Those in the chat, should we try another one? Honestly, let's try I think the Ronnie one is much better. Yeah, I think the Ronnie one is much better. But I'm not sure. Or you can try this for my friend, Joshua. Yeah, Joshua is also my friend. Yeah, we can try his as well. Oh, and remember there is also Nemo models. Yeah, there's also Nemo models. So we try this, then maybe we end the stream now. Yeah, we have a strong baseline, honestly. Yeah, you really have a strong baseline. 0.58 is actually good. Yeah, 0.58 is actually good, but now we have to beat 0.31. Yeah. We have to beat the 0.31. But you can also further fine-tune the fine-tuned models. So for example, if my model scores 0.60, you can further fine-tune it. Use that as like the baseline to further fine-tune it, instead of like pre-training from the base wave to vec model. Yeah. I need to know who are my two loyal viewers who have stayed until until now, man. Shout out to you two guys. Okay, we're going to end the stream at 22:30. It's current. We still have like 15 minutes, so let's hope we find a better baseline within those 15 minutes. If we don't, I think we're going to end the stream now. Yeah, and then tomorrow we try Nemo models as well, baselines, no fine tuning, and then if time allows, we do one fine tuning. We go through the fine tuning process. Yeah. But until we have a strong baseline, to beat, yeah. Okay, let's get to. I think this is too close now. Top 3. Let's get to top 3. I think this is too close. We can get to top 3. Like, yeah. Hopefully we get a better baseline. But the Think one looked so good, bro. Like that was perfect Swahili. Like that was perfect Swahili. It was better than mine, and I'm shocked. Why is it performing like 0.02 better than mine? Mine was like actually terrible. Yeah. After Joshua, we try. There's also a good one called Alam Shah. Yeah, there's also a good one called Alam Shah. Alam Shah. Yeah. Yeah. This one was also a good one. This was a good baseline as well. 0.1963 word error rate. But remember, this was trained with all the data set. This was like a 2023 one. We have 2025 data, so you can use this as the baseline and then perform further fine tuning to improve it. But this one was also a good baseline. Yeah. Shout out to whoever Alam Shah is. I don't know. I have no idea. So yeah. I think we can get we can even add more batch. I mean, but the batch to improve the processing. Yeah. Joshua, I hope your model performs better. I hope your model. We need a strong baseline that gets us to top 3. I hope this is it. Yeah. Whoa. Whoa. Nah, this we can't even submit it. That's it's not even like transcribing anything. So sorry Joshua. You go to the next. Yeah. Let's hope this one performs much better. Nah. Adib Schneider, I'm really sorry. Yeah. This was okay, this is very good. 0.1481. Much better than Alam Shah's model. So this is the next. Honestly, if this doesn't get us to top 3, I'm sorry guys, because like this, mine, Adept Schneider one, and the Julius one was like the top models. So we need to like further fine tune them with the new data, with the new 2025 data maybe. Yeah. So next will be Adept Schneider. Yeah. I hope he's not going to be mad. So. Yeah. Yeah. Did increasing the batch size make it slower or faster? It just reduced the number of steps, but the processing speed still remains the same, I bet. Yeah, but it's only 2 minutes remaining. Yeah, honestly, I don't think we'll test the Adib Schneider one because our 15-minute window is ending. We now have like 9 minutes. Yeah. So to my two viewers who are still here, shout out to you. Thanks for being here. I'll upload this video on YouTube. Yeah. So let's submit this, then maybe we call it a night. Or if the 9 minutes window will still be there, then we can test the Adib Schneider one. Okay, this is not even accurate. Sometimes it's like 2 minutes. Yeah, just need to be patient. And happy birthday to my brother Timothy. Happy birthday to my brother Timothy. A loyal viewer of these streams. So happy birthday to my brother Timothy. Hope I wish you more success in this coming year. And may you keep winning, bro. May you keep winning, bro. May you keep winning. Yeah, hopefully this. Let's see. Upana baina ya mita 64 na 75. Okay, this is perfect Swahili as well. Yeah, that is perfect Swahili. That is perfect Swahili. Hopefully it's much better. Yeah. If it gets us to top 3, if it gets bro, I told you this was a very strong model. Yeah, I have tested it out for some time. Nice. We're getting closer. We are getting closer. Yeah, goal is top 3. Now we test the last model. Just save and pin this revision. So how to track your progress. Yeah. Revision history. So this scored 0.55. So that's how you track your progress. You save and pin revision and then you rename it however you want. Yeah, so let's try my brother's model. Hopefully it performs well. Yeah, honestly, don't go and start fine-tuning from scratch. You see these models that are performing well already without even fine-tuning. These were fine-tuned before though, with old data. Just go and fine-tune them with new data. Yeah, don't start from the base like web-to-vec model. Start from these base models and then try to improve them. Yeah. Yeah. Improve them by training using don't like train them on 2020. For example, this Alam Shah model uh, was trained in 2023. Where can I see the dates? It, almost 2 years ago. So go and find data that was not present 2 years ago and fine tune this same model using the new data. Yeah. Yeah. Don't start from scratch. Don't start from scratch. Yeah, we test this last model and then we go to sleep. Um, yeah, but I believe this was a very strong model in our previous hackathon. So this will give a very strong baseline, I hope. Yeah, we test this and then we go. Bro, my two viewers, can you comment so that I know I'm not alone? Yeah. Yeah. I feel like we can get to 0.50. And these two, I'm not really sure. I feel like they have already fine-tuned their models. Yeah. But thinking about like, so a 0.20 improvements, yeah, that's impressive. Yeah. Yeah. We test this, then we go to sleep. We go to sleep, man. Whoa. Model is not defined. Error loading model or processor. Please ensure, bro. Why are these models leading to like session crashes? Like I'm not sure why they are leading to session crashes. Even mine led to a session crash. Like the memory, I'm not sure why they are leading to this. Yeah, I'm not sure. I'm not sure why. But that's a sign for us to go to sleep. Yeah, we are way past our time limit. Supposed to be 1 hour 30 minutes. I'm not sure why it's leading to a crash. The system RAM is pretty high, GPU RAM as well. Yeah, so like it crashed again. Like I don't think you can see on the stream though, but it crashed. Yeah. Yeah. So I think this is a sign for us to go to sleep. So go and try all the models on Hugging Face. Don't assume any. Just try all of them. You still have time. I think this competition runs for like 2 months. So try all the baselines before you start your training. Save yourself some time. Use those base models as the starting point for your fine tuning. Yeah, and hopefully you win this competition or we win this competition. So thanks for joining the stream. Shout out to everyone who joined the stream. Adios. Adios.